Hello student, today in this class let's we discuss about the dispersive power of a diffraction grating. And this is the topic related to the fourth physics paper of the Danagiri University. By the way, I am Dada Perez from Government Degree College, Chengiri, to discuss about the dispersive power of the diffraction grating. So it can be defined as the ratio of change in the angular diffraction to the corresponding change in their wavelength of light is called dispersive power. So it's the ratio of the change of an angle of diffraction to the corresponding change in the wavelength of the light. So this is called the dispersive power of the grating. So it is denoted by and is equal to the D, and it is denoted by D and is equal to the. So see here, the dispersive power of the grating can be ratio of the diffraction d theta, and the corresponding change in the wavelength is d lambda, change in d lambda. This ratio is d theta by d lambda is called the dispersive power of the grating. And this a plus b, usually for plane transmission grating, we know that a plus b into sin theta is equal to n lambda. N lambda is the phase uh, difference, and a plus b is the grating element, and the sin theta is the angle of sine of the angle of refraction. So when this a plus b sin theta is equal to n lambda is differentiated with respect to lambda, that is a plus b sin theta differentiate is cos theta into with respect to d lambda, that is d theta by d lambda is equal to n lambda means 1. So a plus b cos theta d theta by d lambda, and this leads to d theta by d lambda is equal to n is the number order, nth order, and a plus b into cos theta gives the dispersive power of the diffraction grating. So d theta by d lambda can be denoted as omega. Omega is equal to n a plus b cos theta. This is the dispersive power of a diffraction grating. So omega, and usually d theta is the angular dispersion between the two spectral lines having the wavelength difference. And this dispersive power of grating is, from this equation we can say that is directly proportional to the order of spectrum. If the order of spectrum increases, the dispersive power of the grating is increases. So when, and inversely proportional to the grating element a plus b, it is uh, number of lines per unit length of the grating. So it is inversely proportional. If their number is increases, the dispersive power of the grating decreases. If it is decreases, then its value omega is increased. So and inversely proportional to the cos theta. So orientations, that is inversely proportional to the cos theta. If theta is 0, then cos theta is 1. This gives the maximum, that is the maximum value that gives the angular dispersion is minimum. Dispersive power of the grating. And if you take for the smallest change linear separations, the two spectral lines of differing in their wavelength d lambda and the focal length, then the linear dispersive power, consider for linear dispersive power, is equal to dx by d lambda is equal to f into d theta by d lambda. F is the focal length, so f value into d theta by d lambda is equal to n divided by a plus b cos theta. This is gives the power of is given by that one. Okay, this is all about the dispersive power of a diffraction grating. Okay, thank you very much.